11 is area. The numbering's a little bit off here. It says unit 10, but this is unit 11, day 1. We're going to talk about the area of parallelograms and triangles. So we have 4 formulas we're going to see today. Some of them are pretty similar. These first 2, area of a squared, area of a rectangle, I'm kind of hoping that you already know or are familiar with. This isn't anything too crazy. So these first 2, area of a square, we know that if we take the side of a square, we multiply it by itself, side squared, we can get the area of a square. I believe that's number 2 on your cheat sheet if you want to fill that in, side squared. And then the second one, area of a rectangle, also hoping that you probably know this or have known this for a very long time. The area of a rectangle is the base times the height. Doesn't really matter which one we pick to be base and height. We got base times height. We know those, right? The next one that we're going to see is the area of a parallelogram. We talked about parallelograms way back when in the quadrilaterals unit. A parallelogram has opposite sides parallel to one another, but it doesn't have those right angles in the corners like a rectangle does. The area of a parallelogram formula, however, is the same as the area of a rectangle formula. It is area equals base times height. So we have a base. It can be either one of the sides of your parallelogram can be the base. The most important part is that your height of your parallelogram has to form a right angle to that base. Height is perpendicular. Always. So if I take a look at these 2 parallelograms, sorry, I'm zooming in and out all crazy. If I take a look at these 2 parallelograms, I can pick the longest side to be the base. That's totally fine. But then I have to make sure that the height is perpendicular to that base. So I could either pick the height to be here. Maybe I want the height to be outside. That's fine too. That can be my height. If I want to choose the shorter side of my parallelogram to be the base, the same rule applies. I got to turn this sideways, and I have to make sure that my height is perpendicular to this base. Wherever I choose the base to be, height is going to be perpendicular. Notice I did not choose the other side to be the height. That height is not just the other side of your parallelogram. And why does this formula work? It's probably, you can see it, very visual here. But if I take this piece of my parallelogram and I instead move it over here, we get that nice rectangle shape here. Right. So that's why it's the same formula. Nothing crazy, new information there, right? Just a parallelogram. So parallelogram, rectangle, same formula. And then the last one that we're going to look at is the area of a triangle. If we think about taking a parallelogram or a rectangle and cutting it in half, we get the area of a triangle. So we can see here, if I cut a parallelogram or a rectangle in half, I get a triangle. That's why my formula is area equals 1/2 base times height. Some people like area equals base times height over 2. Again, we can pick whatever side we want to be the base, but that height has to be perpendicular to it. So if I take a look at these triangles here, if I pick this to be my base, my height is going to go from the top of that triangle down to the base to form a right angle. If this is my base, I have to go from the top of the triangle all the way down to the base, right angle. Same thing over here. If this is my base, sometimes if I go from the top of the triangle down to the base, look at that, my height is on the outside. But that height still is going from the top all the way down to the base, and we might have like a little dotted dashed line in there to show it's outside of the triangle. Those are our 3 formulas. Make sure that they are filled in on your little half sheet so that we can keep track of all of those. Next, what is the unit of measurement for your answer if you are asked to find the area of a shape? Let me give you an example. If I draw a triangle, this is a rectangle. If I draw a rectangle and I say that this is 2 meters by 3 meters, I would say that my area is what? Yeah, Dahlia? 6 meters squared. We are multiplying 2 meters times 3 meters. We are getting 6 meters squared. All of our units in this unit are going to be units squared. I'm going to be looking for that in all of your answers, that you have some kind of units squared. Good? Okay, flip it over. Let's get through some of these nice, easy examples. The first one is a square. Our formula for a square is we take the side squared. So I'm going to take this side length, which is 25. Area equals 25 squared, or 625. I'm going to use my units, centimeters squared. There's my answer. I do want to see the initial step where you have plugged things into a formula. So that first step where I say 25 squared, that's fine with me. That's what I want to see. I should flip this page. Next one, number 2 is a triangle. Clearly, I'm going to do 1/2 base times height. My base here is 12. My height here is 4. So my formula is area equals 1/2 base times height. 12 times 4 is 48. 1/2 of that is 24. And I have feet squared. Let me know if I'm going too fast on these easy ones, but I think we can just keep breezing through. Number 3, now I'm looking at a parallelogram, okay? I need to be able to pick a base and a height. So I'm looking for where are things perpendicular. I only see one right angle in this entire diagram, and it's in this corner. So that means this is going to have to be my height, and this is going to have to be my base. If I don't see a right angle, then I do not have the height. So this area for a parallelogram, area of a parallelogram is just base times height, 16 times 10, or 160. And when I don't have a unit, I'm going to write units squared. It might be useful to make yourself a little note over here that our height is not 12. 12 is the other side of that parallelogram, but there is no right angle there. Therefore, we cannot use that as my height. Everybody good with that? Okay. What do we think about number 4 then? Another parallelogram, what's the setup? What am I multiplying together? What are we using as the base? Caitlin? Perfect. So then what's the height? 3.5 centimeters. Look at how it makes that right angle. I do not want to see us using this 4.6 as our height. Height is not 4.6. The area of this parallelogram is 2 times 3.5, or 7 centimeters squared. Questions? We're good on that? The next one, I think they start to get a little trickier. Just a little bit. I'm looking at shaded regions quite often in this unit. So the thing that I'm trying to find is just the shaded part, not that little dotted area. What's going to be the base of this triangle, do we think? Go ahead, Caitlin. 7.8 is the base of this triangle. Perfect. Then what's the height of this triangle? Yeah. 5.6. Notice this right angle going to the base. So the base is 7.8. The height is 5.6. I'm going to do another angry face. I got a lot of angry faces in this unit. The base is not 9.8. That 2 is on the outside of my triangle. It's there to confuse you. They do that quite often. So make sure that when you're counting the base, you're literally only looking at the part of the triangle that's actually there. Area here is, oops, oh my goodness, 1/2. There it goes. Base times height, 7.8 times 5.6. And this is going to get me a not fun number. I think it's 21.8. And I'm good with 1 decimal place, units squared. Good on that one? I'll make things a little bit more complicated. Number 6 is a rectangle. Rectangle formula, very easy, base times height. However, we are missing, I don't know, we'll call it the base. Let's say I know that my height is 33. How am I going to figure out what this missing base is, do we think? Aubrey? Yeah, we're going to use tangent. So we have a bunch of methods that we've seen when we did like right triangles and stuff like that. SOHCAHTOA, sine, cosine, tangent, super common one. Another super common one that maybe we look for first is special right triangles. So your 45, 45, 90s, your 30, 60, 90s. I don't have that here, so I'm going to have to do SOHCAHTOA, which isn't as fun as 30, 60, 90s, but we're going to do it. So I have the opposite. I have the adjacent. This is going to be tangent of 10 degrees equals opposite over adjacent, x over 33. To solve this for x, I'm multiplying both sides by 33. 33 tangent 10 equals x, and I believe that's going to get me something like 5.8. I'm going to fill that in right here. So once we've done the complicated step, now we just go to the area, which should be very straightforward. We're going to do 33 times 5.8 to get the area of that rectangle is 191.4 units squared. Any questions on that one? So some strategies we're looking for. So SOHCAHTOA is one of them. What do we think about number 7? The perimeter is 36, so that means each one of those sides is what? Caitlin? Perfect. Let's fill that in. So I know the base of this triangle. The base here is 12. I don't have a height of this triangle, so let's draw it in from the top down to the base, forming a right angle. That's going to be my height. How am I going to find that height? Dahlia?
Well, like, isn't the height like a bisector, like it would be like 6 from the base?
So each piece of this base is 6 and 6. So then how are we going to find that height? Aubrey? I want more exact values than Pythagorean theorem. I want more exact than Pythagorean theorem. I don't want to round. Any ideas? We had a bunch of strategies in that right triangles unit, right? We had SOHCAHTOA, Pythagorean theorem, special right triangles. Do we have a special right triangle in here that I'm leading you towards? Okay, this is a triangle with 3 equal sides. We call that equilateral, right? If it's equilateral, we also know that it's equiangular. So all of those angles are going to be the same. Each one of those angles in this triangle is 60 degrees. If I cut that angle that's 60 degrees up at the top in half, that means that this little sliver is 30. So maybe I draw this off to the side. This is 6, 12, 60 degrees, 30 degrees. So what is this height? In special right triangles, to get that long leg, we multiply by, oh boy, Aubrey? Radical 3. So I'm going to take short leg, which is 6, multiply it by radical 3. That's 6 radical 3 here. If you don't remember your special right triangles, now's a good time to refresh. So that height ends up being 6 radical 3, and now I'm going to plug it into my formula. Area equals 1/2. The base of my triangle was 12. Don't use that 6. Remember that the whole base was 12 times 6 radical 3. Now you can put this in your calculator and round. Some of the questions will say use exact values. That means I want the radical in your answer. So to do that, I would do 1/2 times 12 is 6. 6 times 6 radical 3 is 36 radical 3 units squared. However, if it did not say keep it in exact values, I would accept 62.4 units squared as well. They're the same. Any questions on that one? Okay. The last one in number 8, we call this a composite figure. That's when we stack shapes on top of each other, and we're trying to find the entire area of this shape here. In order to do that, we're literally just going to find them separately. I see 2 different shapes. Down here, I see a square. The area of this square is 15 squared, or 225 feet squared. Up here, I see a triangle. The area of this triangle is 1/2. The base is 15. The height is 10.6, which gives me 79.5 feet squared. So the total area, I'm going to call it area sub T, is 225 plus 79.5, which is 304.5 feet squared. Any questions on this?